Hi class, I'm going to work through some homework examples from section 3.5. This will be application word problems. I've selected a variety of word problems to include in this video, and you will definitely need your calculator. Okay, let's start with simple interest problems. The simple interest formula that we talked about in class is interest equals principal times rate times t. And so this problem we have I equals 110, so we'll go ahead and substitute that into the formula. P is unknown, so I'll leave it as a capital P. The rate is 5.3%, but remember what we have to do with rate. We've switched the percent to a decimal, and then t is 5. And now we'll just solve for P. Okay, when we multiply that together, it's 0.265. Then we have our capital P equals 110. Divide both sides by 0.265, and P equals, and so the principal would be $415.09. Okay, let's try that again. Here's the formula again. It's I equals P RT. In this problem, the interest is $36. The principal is $360. This time we're missing the rate, and the time is 2 years. So the first step I want you to do is multiply 360 times 2. This is 36 times 720R. Divide both sides by 720, and we have the decimal 0.05, but a rate is a percentage. And so one more step, I want you to change that decimal into a percent, either by multiplying by 100 or moving the decimal 2 places to the right, but the R as a percentage would be 5. Take a look at this word problem. An Olympic-sized swimming pool in the shape of a rectangular solid has a volume of 7,000 cubic meters, a length of 50 meters, and a width of 40 meters. What is the depth of the pool? Okay, so there were some common formulas that I showed you in class. To find the volume of a rectangular solid, this is length times width times height. In this problem, the height is the depth because we're talking about a swimming pool. So we do know that it's 7,000 is the total volume, and we know it has a length of 50, a width of 40, and the depth is what we don't know. The first thing I need you to do is multiply 50 times 40. So now this is 7,000 equals 2,000 H. Divide both sides by 2,000, and the missing dimension is 3.5 meters. Okay, next word problem. A 980 milliliter intravenous bag is attached to a patient with a tube and is empty after 7 hours. At what rate does the solution flow through the tube? So we have a total of 980. I want you to divide it by the 7 hours. And that will give us the unit rate. How many milliliters empties out every 1 hour? 980 divided by 7 is 140 milliliters per hour, and that's your final answer. Next, let's tackle this mixture problem. It says determine the number of units of solution 2 required to obtain the desired percent alcohol concentration of the final solution. Then find the amount of the final solution. I went ahead and took a screenshot from the textbook just to remind you of the mixture equation that we're going to use. I'm also going to draw a picture, and in our first test tube we have 10% alcohol, rubbing alcohol guys, not drinking alcohol, and we have 20 gallons. We're going to then mix it with another concentration of alcohol. We call it concentration number 2. That's 40%, but we don't know how much to put in there. So I'm going to call that X gallons. And then it equals our final beaker, and we want it to be 34%. Now, what is that final amount going to be? Well, I know solution 1 has 20 gallons. Solution 2 has X gallons. I know when I mix those two together, I'll have 20 gallons plus X gallons. That's what we're going to write for the amount of gallons that the final solution will have. I'm going to erase my beautiful picture, and I'm going to convert this into an equation, just the same picture that I have here. It's going to be 0.10 times 20 plus 0.40 times x equals 0.34 times x plus 20. All right, pull out your calculator. 0.10 times 20 is 2 plus 0.4x. Equals, this part I need to do the distributive property. This is 0.34x plus 6.8. Now we're just going to solve this equation. I'm going to subtract 0.34x. This is 0.06x. Okay, now the equation is 2 plus 0.06x equals 6.8. I'm going to subtract 2 from both sides. So now the equation looks like 0.06x equals 4.8. One more step, divide both sides by 0.06 to get x equals 80. Now back to our original problem, we called the amount of gallons of solution 2, we called that x gallons. And so this first question asks the amount of solution 2, that would be 80. Now to find the amount of the final solution, all we have to do is take the 80 that we just found out was solution number 2 and add the 20 gallons from solution number 1. And so the final solution will be 100 gallons. Now that's tricky, that takes a lot of steps, but with practice, you'll get really good at it. Okay, next, let's talk about driving. 2 cars start at a given point and travel in the same direction at average speeds of 45 miles per hour and 52 miles per hour. How far apart will the cars be in 8 hours? First, the green car, after 8 hours, if it's been traveling 52 miles per hour, that's 52 times 8, which is 416 miles. The red car is traveling 45 miles per hour. So after 8 hours, the red car has traveled 360 miles. And now this is the easy part. To find the distance between them, we're going to subtract those 2 miles. 416 minus 360 equals 56 miles. So after 8 hours, these cars are 56 miles apart. Okay, this is a work rate problem. It says one person can complete a typing project in 5 hours and another can complete the same project in 9 hours. How long will it take the 2 people working together to complete the project? So we're going to give a numerical value to the project of 1. So person number 1 can finish the whole project in 5 hours. So that person's rate is 1/5 because every hour that person can complete 1/5 of the project. Person number 2 works at a rate of 1/9 because every hour that passes, 1/9 of the project is complete. If we combine these 2 rates together, we're looking to see how much time it would take if 2 people are working on the same job. And so just like we did in class, we're going to set up the equation 1/5 t plus 1/9 t equals 1. That's the completed project. Before we can add these fractions together, we need to find common denominators. 45 would be a common denominator, and so the numerator of 1/5 would now be 9. So this will be 9 over 45t plus 5 over 45. I just multiplied that second fraction by 5 over 5 equals 1. Now we can add those 2 fractions together because they're like terms. They both have the variable t. This is 14 over 45. T equals 1. Okay, now we're going to divide by a fraction. Now we did this in an earlier chapter. Remember, instead of dividing by a fraction, we multiplied. I had you multiply by the reciprocal. That's exactly what we're going to do here. We're going to multiply both sides by the reciprocal, which is 45 over 14. On the left side, when you multiply that fraction by its reciprocal, do you see that the 45s will cancel and the 14s will cancel? That's what we wanted to happen. Now we just have t equals 45 over 14 times 1 is 45 over 14. Now this problem didn't specify if it wanted you to leave it as a fraction form or not. But again, this is why you have multiple chances to type in the correct answer. This is the answer that WebAssign had, 45 over 14. You could try to convert it to a decimal and see what WebAssign would do. The decimal version is 3.214, but again, it didn't tell us which place value to round it to. But the final answer is 45 over 14 hours. Okay, these word problems are no joke. They can certainly get tricky, but please let me know if you have any questions on this homework assignment.